Hey guys, welcome back. This is Mr. Kim here, and today we're going to be going over the Unit 4 review guide. Now, this whole unit was very math heavy, understand that, and I'm here to make sure that everyone has all the knowledge in place before we take this unit test, okay? Now, mole conversion, there are three molar conversions that you're going to have to know for this test. Yes, I will provide them for you on the test, but however, you need to know how to utilize these molar conversions, okay? So the first one that I'm going to tell you is that 1 mole is equal to how many number of particles, okay? Now, this is the Avogadro's number, by the way, right? That it tells us that it's 1 mole of something, and there's this many number of things, right? Or particles in this case, okay? So that's the first molar conversion that you're going to have to utilize for this test. You'll have to use. The other one is the molar volume one, right? This applies only for gases, all right? Now, if I had 1 mole of gases, the amount of space that it will occupy is 22.4 liters, okay? Now, again, this only applies for gases at STP, okay? Only applies to gases at STP. Now, again, a quick note of reminder, STP stands for standard temperature and pressure. Temperature at 0 degrees Celsius, which is the freezing point, and pressure is going to be at 1 ATM. 1 atmospheric pressure, okay? So that's about how much atmospheric pressure that you're feeling right now, okay? So again, only for gases. Now the third one is going to be the molar mass, right? Now, how do we convert the amount of grams to moles is you're going to have to apply the molar mass here, right? So that is always going to be found in the periodic table. To give you one example, I'm going to draw, just move that to the side and make it a little bit smaller. Here we go. So let's do carbon, okay? 6, carbon, 12, okay? Okay, so if you look on the periodic table, each element box, it's going to have a number right beneath the symbol here, the 12, right? Now, that is your molar mass, all right? A quick reminder, molar mass is how many grams of something will equate 1 mole, okay? So for this case here, if I had 12 grams of carbon, okay, that would give me 1 mole of carbon, okay? And if you look on the periodic table, it will vary, right? Each element has its own particular unique molar mass, okay? All right, so these are the 3 conversions that you are going to have to use in converting between moles to grams, grams to moles, moles to liters, and vice versa, okay? So let's go ahead and take a look. I'm going to go ahead and go over some of these questions. So I definitely answered number 1 here already, right? This whole thing is number 1, right? So what conversion factor allows you to convert between moles and number of particles? We just did that, right? So that's number 1. And number 2, what conversion factor allows you to convert between moles and grams? That is going to be the molar mass, right? And that is right here, okay? Each element, each compound is going to have its unique molar mass, okay? So that example just now, carbon, it's a single thing, single element. That's why 12 grams of carbon is 1 mole of carbon. Now, what if I had like a compound, for an example? For example, if I had CO2, right, which is the gas that you're breathing out right now every time you exhale. Carbon dioxide. Okay, let's go ahead and try to find what the molar mass of carbon dioxide is. Carbon 12, right, per carbon, and there's only 1 carbon here, so that's it. Now, what about oxygen this time? On the periodic table, you'll see that each oxygen is 16. But if you look, CO2, carbon dioxide, right? Di means 2. So I'm going to multiply that by 2, which will give me 32. All right, so if I add up the number of carbon, the molar mass, and the oxygen molar mass here, so that gives me 44 grams of CO2, 1 mole of CO2. Okay, so that's the molar mass of carbon dioxide. Okay, yes, I know you're probably thinking, wait, hold on, but these are gases. Do they have masses too? Yes, they do. Okay, gases also have mass. So if I were to put, okay, if I had 44 grams of carbon dioxide, oops, sorry, that would give me, so again, 44 grams of carbon dioxide, that would give me 1 mole of carbon dioxide. Okay, there you have it. That's the molar mass. Number 3, what conversion factor can you use to convert between moles and gases? And this word here, STP, it really should give it away, right? STP only applies for gases. You need to use the molar volume conversion factor. That is written up here, that part, right? So, molar volume, that's going to be this equation up here. 1 mole of gases, it will occupy 22.4 liters of gases. Okay? All right, so those are the 3 equations that you're going to need throughout the test. Again, I will provide them for you, so do not worry. Unless you want to write that down in your periodic table, which is fine also, okay? Now, let's go ahead and take a look at some of the examples below. I'm going to start off with, let's see, percent composition here. Okay, good. To find how much percentage each element occupies within the big compound that it's part of. Okay. All right, so let's go ahead and try to find the first one here. Li3PO4, that is lithium phosphate. Okay, we're going to go ahead and try to find out, okay, so if I had, what percentage does lithium, what percentage does phosphorus, what percentage does oxygen? They occupy within this big compound, okay? So let's see. The first step you're going to have to do is find the molar mass of the entire thing, okay? So let's go ahead and try to find lithium first, okay? On the periodic table, lithium is approximately 6.9. I'm going to multiply that by 3, okay? Because there's 3 of them, obviously. So that gives me about 20.7. And that is for lithium only, okay? Now, what about for phosphorus here? Each phosphorus is approximately 31, okay? I know I've rounded up a little bit, but that's okay because that's very, very close to 31, right? Okay, now for oxygen, each one is 16, but there's 4. Okay, so that gives me 64. All right, I'm going to go ahead and quickly add those up. So that's 95. Add those together. 115.7. Okay, so what exactly is 115.7 here? That is the molar mass of this entire compound here, this lithium phosphate, okay? So let's go ahead and determine the percentage makeup of lithium inside of this big compound. So what I'm going to have to do here to find lithium, okay, lithium was what, 20.7, right? Now I'm going to divide that by the entire thing here, okay? Now that's going to give us a decimal, but we don't want that. That's why we want to multiply by 100 so that we can get the percentage makeup, right? Just doing that on my calculator really quick. Okay, so that's about what, 17.9%, okay? You can round to the nearest tenth if you like. I recommend doing tenth. If it's to the 100th, your calculation is going to be, your rounding is going to be a little bit tricky because you do want to make sure that they all add up to 100% at the end, right? So that's 17.9%, okay? Okay, so that is done. I'm just going to move that out of the way. I'm going to put it right there because I need the space. Let's go ahead and try phosphorus now. Okay, phosphorus, there's only 1 and only 31, right? And I'm going to divide by the entire thing, which was 115.7. Again, multiply by 100 so that I can find the percentage. Just quickly doing that on my calculator. That's about 26.8%, okay? Okay, so that's good. All right, same thing as what I just did. I'm gonna move that out of the way because I don't need that anymore. But I am gonna keep those percentages for later because I need to make sure that they all add up to 100%. Otherwise, something's wrong, right? Let's go ahead and do oxygen now. Oxygen, there's 4 of them, and 64 for the 4 oxygens that we have. Divide that by the entire thing to see what the percentage makeup of that is. 64 divided by 115.7. So that gives me, what is that? 55.3. Okay, so let's see. 55.3. Now, you want to make sure, we're not done here, right? There's one last step that you have to make sure that you check at the very end, is that do all these percentage makeups, do they add up to 100%? And it appears, yes, they do. Awesome. They all add up to 100%, which is exactly what we're trying to do here, right? To find the percent composition of each element, okay? Great. So that's done. That's one question. I'm going to move on to do an empirical formula question. How about that, okay? Now, a quick note of reminder. Empirical formula, it tells us the chemical formula of an unknown substance, okay? Now, we are using the percentage composition, what we've determined just before, right? The lithium, phosphorus, and oxygen. So we're using the percentage makeup, and we can actually determine what the chemical formula that is using those percentages, okay? What I'm going to do is, okay, I am going to actually turn these percentages into the number of grams. And let me just explain to you why I'm doing that, okay? Because whatever this compound is, I know that it's carbon something and hydrogen something, and what's the other one? Oxygen something, okay? So our goal right now is to find these missing boxes, and that will be determined through these percentages, okay? So again, going back to the reasoning of why I'm just saying that's not percentages but for grams is because no matter how much amount that I put inside this, let's say, machine that tells us the empirical formula, 26.1% of whatever amount is always going to be carbon, and 4.3% hydrogen, and 69.6% oxygen, okay? So that could be 1 gram that I could put inside this machine, or 100 grams or 1,000 grams, doesn't matter, okay? Now, the reason why I'm just gonna turn that into grams is because they all add up to 100 grams. It's very convenient, and it's very easy to calculate. So that's why, okay? Okay, so with that in mind, let's go ahead and get started, okay? So just turn those percentages into grams. And our first step is to convert from grams to number of moles, okay? So we can convert from grams to moles by using the molar mass of each element, right? So let's go ahead and give that a try. 26.1 grams of carbon, okay? If you look on the periodic table, carbon, 12 grams of carbon is 1 mole of carbon, right? So the grams of carbon, they go away. Doing a quick math here, divide that by 12. Okay, so I got 2.175 moles of carbon, okay? All right, so that's good. I'm just gonna shrink that a little bit, just put it aside because I'm gonna need it later, okay? Okay, so what about hydrogen now? We got 4.3 grams of hydrogen, okay? Look on the periodic table and you'll see that, okay, hydrogen is 1.01 grams of hydrogen is 1 mole of hydrogen, okay? Now, if you don't know where I got that 1.01 from, some periodic table will just say 1, some will say 1.01, some will even say 1.008, okay? So again, I'm just using the molar mass that is written on my periodic table, which is probably the one that you guys are using as well, okay? So the grams of hydrogens are going away, so I'm going to do 4.3, divide that by 1.01. So that's going to give me, let's see, 4.257. Okay, now why am I reporting to the nearest thousandth? Because if you look back to the number of the moles of carbon here, I left that in the thousandth decimal point. So I'm just being a little consistent here, okay? Okay, same thing. I'm just gonna shrink that a little bit and I'm just gonna leave it in the middle. Yeah, sure, why not? Okay, let's move on to the third part, which is oxygen, right? I got 69.6 grams of oxygen on the periodic table. Again, 16 grams of oxygen is 1 mole of oxygen. Okay, so the grams of oxygen, they go away. 69.6 divided by 16. Okay, so okay, 4.35. That's all I have for this one. Okay, so what am I doing right now with this number? Well, let's first shrink this a little bit. Oop. Okay, here we go. Now, see, what I've just found, guys, is the molar ratios, okay? What that means is that, okay, the numbers that I just found, 2.175, that's going to go in here. And 4.257 is also going to go in here. And 4.35 is going to go inside here. However, if you look very closely, okay, well, we can't have decimals of them, right? And you want to make sure that they're in whole number ratios, right? So what you're going to have to do here is just simply divide by the lowest mole count here. And if you look, this is going to be the lowest mole, right? So here's what I'm going to do. I'm going to divide by that very same number. And that's going to give me 1, right? I'm going to do the same thing here. Divide by 2.175. And that's going to give me a 2, right? Same thing here. If I divide by 2.175, it's going to give me like roughly 2, right? They don't have to be like the whole number exact right on the dot, but you know, sometimes it's going to be slightly over or slightly less, and that's okay. Okay, so these are the proportions in ratio that they are combined to. All right, so what that means is that this 1 here is going to be 1 here, this 2 is going to be 2 for hydrogen, and this 2 is going to be 2 for this oxygen. And that's how you find the empirical formula of the following unknown substance. Well, now it is known because we found what those missing boxes were, right? C, H2, and O2. That is the empirical formula for this compound, okay? Okay, let's go to the first part and do a couple of questions, okay? So I'm going to go ahead and do, let's see, one of this one and one of this one. How about that, okay? All right, let's go. How many particles make up a 97.8 gram sample of calcium nitrate? Okay, so you're going to have to name this ionic compound first. Calcium is Ca2 plus, nitrate is NO3 1 minus. Okay, so in what ratio are they going to combine in? Well, notice that the charges are different, right? 2 and 1, which means they're not going to be combining in 1-to-1 ratio. Therefore, you're going to have to apply the crisscross method, right? Bring down the 1 here, bring down the 2 down here. So they're going to be combining in 1-to-2 ratio. Therefore, this is calcium, parentheses, NO3, 2 on the outside. Boom, there you have it. That is the compound calcium nitrate. Put it away. Okay, so going back to the question, how many particles make up that many grams? Okay, so we're trying to go from number of grams to number of particles here, okay? So I'm going to go back to my first part up here. Is there a molar conversion that will take me directly from grams to particles? Let's see, grams to particles, grams to part. I don't think so, right? What I'm going to have to do is, okay, I'm going to have to go from grams to moles by using the molar mass, right? And then once I have the number of moles, I can go from number of moles to the number of particles right there, right? Okay, so that's what I'm going to do. It's not a one-step process. It's going to be actually a two-step process. Always begin with what is given, which is 97.8 grams of calcium nitrate. Okay? All right, so do we know what the molar mass of this calcium nitrate is? No. Okay, so then we're going to have to determine that too. Ooh, a lot of work, right? So let's see. Calcium is what? Approximately 40. Okay, nitrogen is 14 plus, okay, oxygen. There's 3 oxygens, right? And each oxygen is 16. So 16 times 3. So that's 14 plus 48. Add these two, and I get, what is that? 62. Okay. Now, I'm not done just yet. Why? Because there's that outside subscript of 2, which means I'm going to have to multiply that by 2. So that's 124. Okay. Still not done here, guys. Bear with me, okay? 40 calcium, 124 is the right side. Add these two up, and you get 164 grams per 1 mole, okay? Wow, that was a lot of work, right? So I just found the molar mass of this thing. So I'm going to put it right next to it and just clean up a little bit, get rid of all the things that I don't need here. Okay, so once I have the molar mass of this, here's what I'm going to do. Let's convert that 97.8 grams to number of moles using that molar mass that we just found. So 164 grams is going to go on the bottom because why? We want to cancel out these grams together, right? So that's going to go 1 mole up here. Okay, now once I have everything in terms of moles, how do we go from moles to number of particles? Using the Avogadro's number, right? And that tells us that, okay, if I had 1 mole of anything, in this case, 1 mole of calcium nitrate, that will give me 6.02 times 10 to the 23rd particles. Okay? Calcium nitrate particles. All right, so cross out any units that are unneeded anymore, right? So moles will go away now, and the only unit that's remaining is the number of particles, which is exactly what we're trying to find here. Great. Okay, let's go ahead and punch all that into the calculator, okay? Now, I saw some students last week who were still kind of struggling with, okay, do I divide, do I multiply, what do I do? Well, just remember this, okay? All the numerators, all the numbers on top, you multiply them together. And all the denominators, all the ones in the bottom, you multiply all of them together. And at the end, you divide top and bottom. Okay, I'll show you what I mean. So 97.8 multiplied by, I'm not going to write that 1 in the middle because that's unnecessary, right? All of that divided by 164. That's all you have to do. Okay, so here we go. I'm just punching this into my calculator. So that's 97.8 times 6.02 EE button to the 23rd power. Okay, all of that divided by 164. Okay, and that gives me 3.59 times 10 to the 23rd particles. There you go. That's it. Okay, just gonna highlight that so that you can see that's where the answer is. There it is. Cool. All right, try another one. Find the volume. Oh, okay, so we're trying to find volume this time. By 8.97 times 10 to the 23rd number of particles of nitrogen trihydride, okay? So that is a molecule. How do I know that this is a molecule? Because this name includes a prefix. Tri means 3, right? That's how I know that, oh, that's a molecule. So what is this? It's nitrogen. That's one nitrogen, and tri means there's 3. NH3. Okay? So we're trying to go from number of particles to the number of, well, liters, volume, right? So is there an equation that will help us, that would take us directly from number of particles to volume? Particles to volume? No, there is not. So what you're going to have to do is, okay, I'm going to go from number of particles. So let me just clean up a little bit. Okay, that looks a little bit better. Okay, so I have particles, okay? I will rewrite that because I don't want to confuse anybody with me using the word things. I'm referring to the number of particles here, right? So I'm going from number of particles, and then I'm going to go to the number of moles just like that, right? From moles, here's moles, and I can go to the number of what? Liters, volume, using the molar volume conversion factor. Okay? So that's going to be particles to moles to liters. Okay? All right, so let's go ahead and plan that out before you try different things. Don't do trial and error for this one, okay, guys? Just make sure you think ahead at where you want to go with things, okay? So let's go ahead and set this up. Just move that up here. Okay, here we go. Your starting unit is what is provided, 8.97 times 10 to the 23rd power of particles. Okay, now we know that, okay, if everything is in terms of particles right now, that I'm going to use the Avogadro's number, right? 6.02 times 10 to the 23rd power of particles will always give me 1 mole, in this case, nitrogen trihydride, right? Okay, good. Now everything is in terms of number of moles. Am I done? No, I need to do one more process here, one more step, and go from moles to the number of liters using the molar volume equation. So that, okay, if I had 1 mole of nitrogen trihydride, that would give me 22.4 liters of nitrogen trihydride. Okay, all right, cancel out all the units, particles, moles and moles, great. The only unit that's left is the number of liters, which is exactly what we're trying to find here. Okay, so let's go ahead and do the math. Likewise, I will write it out so you know which ones that multiply unit and divide. So 8.97. I'm going to multiply 22.4. All of that divided by 6.02. Good. That's it. Okay? So here's what I'm doing on my calculator. Do it with me, guys, okay? 8.97. Where's the EE button? And 23rd power. Multiply by 22.4. Great. Now I'm going to divide all of that by 6.02 EE 23rd power. Okay, so that will give me 4 liters of NH3. Done. Wasn't that easy, right? That's it, guys. All right. So this unit is really just, it comes down to, do you know how to use the 3 conversion factors above? First one, the Avogadro's number, the 6.02, that one. And the second one is the molar volume, the only conversion factor with 22.4 liters, right? And the third one is the molar mass. Again, that is found directly from your periodic table. Okay? All right, I'm going to stop here for today. I hope that was helpful. I will hold a review session probably on, I think, Wednesday morning. Yeah, probably Wednesday morning. Until then, see ya.